Think Again TV is produced by Centre for Inquiry, Canada's premier venue for secular humanists, atheists, skeptics, and free thinkers.
So it's a real pleasure. I'm really glad that Jill was able to make time for us this morning. I know she's rushing off to the airport in just over an hour, so we'll try to make the most of our limited time. Jill Tarter is the Bernard M. Oliver Chair for SETI, that's the Search for Extraterrestrial Intelligence, as though you didn't already know that. She led Project Phoenix, which studied about 750 nearby star systems, and now she's heading the SETI Institute's new effort to build the Allen Telescope Array. It's very exciting. We'll hear more about that. Jill graduated with degrees from Cornell and the University of California, Berkeley, and she's won many awards, 2 public service medals from NASA. She's a fellow of the American Association for the Advancement of Science. She was named one of the 100 most influential people of the year, people in the world of the year by Time magazine in 2004. And I love this, she won the Wonderfest's Carl Sagan Prize for Science Popularization in 2005. Oh yeah, and she's a fellow of the Committee for Skeptical Inquiry of the Center for Inquiry. So you're certainly in a welcoming environment here at this Center for Inquiry event, Jill. Thank you so much for joining me here at the Star Spot at the Center for Inquiry's event.
Oh, thank you for having me, Justin. It's been a fun trip to Toronto.
You've been here for the Toronto Science Festival.
That's correct.
Tell me a little bit about that.
Well, yesterday, which is the day that I participated, we had a brunch, early morning event where people tried to imagine what they would like to say to an extraterrestrial if they were given an opportunity to create a message. And it was interesting what the tables came up with. And then I was able to inform them at the end that in fact we may very well have an opportunity to do another self-portrait of Earth and the life thereon, because we're asking NASA for permission once the New Horizons spacecraft has flown by Pluto a few years from now and has sent back all of the scientific data. It's going to be heading straight out of the solar system the same way that the Voyager 1 and 2 have done. And there's no record on New Horizons, but we realized that as long as we still have contact with it and as long as it still has power, it would be possible to upload a message, a self-portrait, into its memory. And we have a lot of technical challenges to make that memory hardened so that it doesn't decay and get the information scrambled. But newhorizonsmessage.com is a website that was just launched last week by John Lomberg and an advisory committee. Right now, asking people to sign a petition telling NASA we think this is a good idea and it should be done. And with enough signatures, we'll go to the agency and say, would you approve this? I mean, the project scientist, Alan Stern, is on board, but we have to get the agency approval. So the first step is sign the petition, and the next step is get involved and become part of creating a message that describes who we are and what we think about and what our planet's like, and hopefully we'll even remember to include all the other life on Earth in this self-portrait.
I love these projects that really engage people, because after all, the search for extraterrestrial intelligence is kind of a search for who we are. And so I think you'd agree it's important, right, to engage as many Earthlings as possible in this pursuit.
Absolutely, I'm all for Earthlings. I always had some reservations about the records that we produced for the Voyagers. They were done by a small team who worked very hard, including John Lomberg, but everybody was beautiful, right? There was no poverty, no disease, no war, so we certainly painted a picture of humans as being, you know, next to angels in some sense. We were perfect, and that's not right. That is not the reality of our existence, and we certainly didn't focus on the rest of the life on the planet.
I want to ask you a little bit more about that connection between us Earthlings and the rest of the cosmos. I don't know if it was the last time you were here in Ontario, but some years ago you appeared on Big Ideas, a TV Ontario program, and you said that if there was one lesson that folks should remember from your talk. It's that we're all stardust. And you're back here in Ontario, so I think it's appropriate that I follow up on that with one of my first questions, and that is, why is that such a central lesson, and how does that inform the SETI enterprise?
Well, I think that we, as humans, want to know where we came from, why are we here, where are we going, how do we fit in, and I think that it's incredibly awesome to realize that the iron in the hemoglobin molecules that running around your bloodstream were actually fused deep in the heart of a massive star that blew up 8 billion years ago. So we are intimately connected with the cosmos. We are really star stuff. And if we can learn to step back and take that bigger look at who we are from a cosmic perspective, I think it helps us to realize that we're all the same. We are all Earthlings, and I think that we should begin trivializing the differences that we perceive among us that cause us to kill one another, to wage war, to not take care of the planet in the way it should be. So Earthling message is very important, and one of the ways you get there is by realizing exactly what your path was, from stardust to the planet to life to us. It's all connected.
When you approach the SETI enterprise, I'm curious if you would say that the existence of ET, extraterrestrial intelligence, is it merely possible, or is it actually probable?
I'm a scientist, and so I'm trying to answer that question, and I don't know the answer to the question. Certainly, if, as we began to have the technology to discover planets around other stars, if it had turned out that there weren't any, that would have made it much less probable that life could be found around other stars. But that's not at all what's happened. We have now found thousands of planetary candidates with the Kepler spacecraft, and another 1,000 from ground-based observations. So it looks like every star has planets, and that's a good thing for life as we know it, because life is a planetary phenomenon. And the other thing that's been happening over the past couple of decades is our appreciation of extremophiles, forms of life that live in conditions that you and I wouldn't be very comfortable in, but they're perfectly adapted and evolved to thrive there. And that's given us the sense that, well, perhaps there's more habitable real estate out there than we might once have thought. So over my career, the universe has begun to look more and more bio-friendly. But that doesn't mean it's inhabited. That's still an open question, a question that we need to ask and develop the observational tools to answer.
As far as the prevalence of life, the commonness of life in the galaxy or in the universe, if we were to find just one more case of Genesis, would that mean it's very prevalent, or would that just mean that it's, you know, a little bit more likely?
Now, number 2 is just an incredibly important number in this discussion. We have one example of life, and it's all connected. It could, in fact, be unique, that the chemistry that led to biology has never happened anyplace else except here. But the moment you find number 2, the moment you see another independent genesis of life that tells you that it's going to be everywhere. I mean, physicists count 1 to infinity. It's just the way it is. You've got 2 examples of something, you're going to have many more.
Gotcha. I want to ask you now a little bit about the SETI enterprise itself, because I'm really curious about what SETI scientists do all day. I mean, are you all just looking through telescopes? Are you on computers? Are you all even scientists necessarily? Tell me about the average day for an average SETI participant.
Well, someone who works at the SETI Institute will be reading scientific papers, trying to get new ideas, understand the possibilities, do a lot of thinking about technologies that are coming along and how they might be incorporated into instrumentation that might detect someone else's technology, because that's really our proxy for intelligence, right? We're looking for technology out there. We have, in the past, built our own instrumentation, so there's been an electronics lab, and you go in and you try and put things together. Right now, we've moved away from that custom electronics because computing has gotten fast enough that we're able to do what we were doing with special purpose electronics before. We can now do it in enterprise servers. And you know, our team sits around and actually observes in their pajamas from their bedrooms, right? It's all done remotely by writing scripts, and the telescope array that we built in Northern California, the Allen Telescope Array, we submit the scripts and they're run on schedule. And the machines are smart enough so that when signals are found that are interesting, they automatically follow up on them. And they continue that follow-up until they've reached a point of extreme certainty, and then we get a call. And we have to get involved as humans. But it's a huge search, so the necessity of automating it has been something we've realized all along, but it's only been recently we've been able to do it.
So given how big the search project is, it's not just astronomers, there must be engineers, there are software designers, all sorts of IT folks.
That's right. It's all of the kind of computing skills that you need in many other walks of life. And at the SETI Institute, although the name is SETI, there are 150 folks who work there, but only a handful that actually work on the search for extraterrestrial intelligence.
Because the mandate's broader, right? Astrobiology?
Yeah, the rest of my colleagues are astrobiologists.
Okay.
And so they spend their days looking at data that are captured by the orbiters around Mars. They spend their time in the field studying extremophiles, trying to understand the origin of life here on Earth, trying to figure out what might be a good biosignature in the future if we're ever able to image a terrestrial type planet and in a way that will allow us to spectroscopically analyze its atmosphere. What might be the telltale signs that say, well, we don't know whether it's microbes or mathematicians, but there's sure some kind of biology going on in that planet. And let's see, others at my institute work on educating the public. We have a large EPO, Education Public Outreach team. We've written curriculum for high schools, for middle schools. We do teacher training and a lot of public speaking and social media. So that's the Institute.
Well, speaking of outreach and public education, you mentioned earlier in our conversation this new project to engage the public. And I'm wondering if you can comment on SETI at Home, the very popular screensaver software that runs on, well, maybe you could answer that question first. Tens of thousands of computers, hundreds of thousands?
Oh, millions, actually.
Millions of computers,
yeah,
right.
There have been, I believe the number is now over 5 million downloads of
amazing.
that. It's over 10 years old. SETI at Home did not invent distributed computing. That was already around. There were a few souls who were trying to crack codes or factor Marcine primes. But the SETI at Home application came along, and it was so sexy and so exciting that it just, wow, it just started a whole revolution. And now there are all kinds of at-home projects that you can do. Fold proteins for cancer research, count craters for NASA, all kinds of great citizen science that have evolved out of this really good idea.
And the project has yielded useful data. Like, it has contributed meaningfully to the SETI program.
The project definitely has contributed meaningfully. It does a random sky survey of the sky that Arecibo, the large telescope in Puerto Rico, can see many times, and it's building up a candidate list of the most probable events. If you see a signal from a particular place on the sky, it doesn't really mean much because it might just be a noise event, or it might be a piece of interference from our own technology. But over the years, as you go back and across that same piece of sky many times, if indeed you continue to see the signal, then it becomes interesting. And so the SETI at Home scientists every year go back down to the observatory and use directors' discretionary time to look back at these particular areas to see if they can recapture the signal. So far they haven't been successful, but that's the name of the game.
Gotcha. So I have to ask the Carl Sagan Prize winner this question. The Carl Sagan Center at the SETI Institute, what's that all about?
That's all about astrobiology, right? So we actually have 3 distinct centers: the Center for SETI Research, the Carl Sagan Center for the Study of Life in the Universe, and our Education and Public Outreach Center. So it's a great place to work. There's a lot of cross-fertilization, chemists talking to geologists, talking to biologists and astronomers, and we have some social scientists working there too.
Excellent. The Allen Telescope Array, which is, I suppose, the next very big thing for SETI, how will that change the game?
Well, the Allen Telescope Array has been in use since 2007, with the first 42 dishes in a radio telescope array. Eventually, we hope to be able to raise the funds to build it out to something like 350. The larger number of dishes will make the telescope more sensitive, able to hear fainter signals. But right now, we use that telescope every day to look at planetary systems. So for the past few years, we've been concentrating on the 100 square degrees of the sky that the Kepler spacecraft is exploring. And we've been looking at all the planetary systems that it has been providing. We used to pick stars that we thought might be good planetary hosts, but now that we know where planets are, that's where we're looking.
Are all of these various projects under the SETI banner, are they entirely privately funded at this point?
No, not at all. The search with radio telescopes or optical telescopes, that is privately funded. But my astrobiology colleagues compete for grant funding from NASA, from NSF, from the USGS, and the educational programs as well. It's just the SETI piece that is no longer federally funded.
I once heard you comment that the search for funding is the hardest of all searches. And I'm wondering if you can comment on, why that is. I mean, given how much of a game changer it would be if we were to detect a signal. Is it just that there is less of an appetite these days for long-term perspective-based thinking in government funding decisions? Is there something else at play?
Well, in my government, we don't know if we're going to get past tomorrow, right? We're likely to shut down because we can't get our business done. In terms of the private fundraising, I think we just haven't asked in the right way. I think that there is an enormous interest in the program. I think it is one of those things that could, at least for a while, be successfully crowdfunded. Nobody has any data yet on whether crowdfunding can work for the long term. So I think here, what we need to do is, despite the bullet, and say, what this kind of research needs is an endowment. Very difficult funding to raise, but we could endow a fund that would provide annual monies that SETI groups could apply against, and we could get as many ideas and different technologies on the telescopes as possible, and just keep going. The universities and organized religions seem to be the only long-term institutions that we know. So they live on endowments of sorts, and so I think that's what we probably need to do for SETI.
When you do, compete for grants from private or public agencies, do they often, ask you about SETI's 50-plus years and how in a project that could last for hundreds of years before, if ever, something is found, how do you gauge progress in a project like that when you are making the case to a potential funder?
Well, it's, yes, potentially a very huge long-term project, but you set goals in the sense that you say, here's my strategy for this year or the next 5 years. I want to take a look at all 3,000 planetary systems that Kepler has discovered, and I want to observe them over the spectral range from 1 gigahertz to 10 gigahertz, using very fine resolution to be able to be sensitive to narrowband signals. That's one discrete search. You can wrap it up and you can say it's going to take me 4 years to do that, and I can report to you how I'm doing on the progress. That's not the same thing as my telling you I'm going to detect extraterrestrial intelligence. I can lay out a strategy on which I can execute, can define other strategies for optical SETI, or for looking for different types of signals. The thing that we've done the poorest job at over this 50 years is finding transient signals that we can have some confidence in. So if a signal is there only momentarily, it's very difficult to know whether you actually detected someone else's technology or your own.
Right.
And right now, as we continue our previous strategies of looking for narrowband signals, we're looking at this array that we've built. We're looking at a spectral imaging correlator, which is a way of making radio pictures, and trying to figure out how we can use that back end, that piece of gear, to deal with this transient problem.
Looking just a bit closer to home in terms of our continued, SETI approach to our own solar system, is the strategy still follow the water?
Follow the water is a good strategy, and I have there are different groups within the SETI Institute that would like to have a debate here about what the best body.
This is the debate room, so
yeah, well, you could get a number of my colleagues going at it here. Is Titan the best place? There is actually some water there, although it's more organic liquids. Water does seem to be frozen in the slush. So Titan, Europa, the liquid water oceans under the crust of Europa, Enceladus. Enceladus is spewing these cryovolcanoes, and out off the surface are coming not only water ices, but there are organics there. I mean, you could just, open a scoop and bring it home. And Mars. We've got a group that really wants to think seriously about getting subsurface on Mars, seeing if we can't detect extant liquid aquifers. So lots of places that people want to go, and they're all serving, they do what scientists do. They give their time to work on instrument definition teams. They write proposals, and they compete them against one another, and they try and get it all funded.
We're probably not looking for extraterrestrial intelligence signals from our own solar system. But
why not? Could be here. There are, sure. I'm a great science fiction fan, right? So I've certainly read all of the novels about artifacts in wandering around the solar system, probes, small probes that have been sent here essentially to scope it out and see what's going on. Even our solar system is big and vast, and we haven't scoured very much of it. There could indeed be artifacts or signals from small spacecraft that we haven't yet detected.
What kinds of signals from a craft that were purposefully sent to study us would we, that would be a very different kind of search, I'd imagine, from the more broad-based SETI enterprise, because in this case you would you would assume that, that whatever you're looking for would be purposefully set out to study us? Would that change the local search?
Well, it would change it in detail because at the moment, one of the things that we use as a standard for recognizing a signal that might be someone else's technology versus something that's our own is we say we expect it to be a point source that moves on the sky the way the stars do.
Right.
Right? It could well be a point source that's moving through our solar system and therefore would have a totally different Doppler signature. At the moment, we'd probably throw it out. If it was detected by our computers, it would probably be dismissed. One of the things we'd like to do is figure out, all right, well, maybe though if we're making a radio image, as opposed to just doing a spectral analysis, we might see that signal moving through our image, and it might become interesting in that sense.
Okay, so putting that to the side, the more sort of bread and butter traditional approach to scanning the far-off stars, although some of them are not that far off. SETI did start with looking at the local neighborhood, as it were. What kinds of signals are you looking for? What do you expect to find if a intelligence is out there and presumably is trying to get somebody's attention?
Well, right now the SETI projects, optical or radio, are concentrating on signals that are deliberately engineered. Signals that look unlike anything that astrophysics can do. So in the radio, for us that means frequency compression. We look for signals that show up at just one narrow channel on the radio dial, not spread across a large number of channels. Astrophysics does the latter. Astrophysics emits over a range of frequencies. This broadcast, right, will have associated with it a carrier at one single frequency, and that is an artifact that we don't see naturally. So that's what we're looking for in the radio, these artifacts, these narrowband signals. In the optical, it's not frequency compression, but time compression. So we're looking for very short, bright pulses, like some large laser flash.
Okay.
Again, nature does not seem to be able to do that kind of coherent emission. So the deliberate SETI programs are looking for obviously engineered signals. The rest of astronomy, however, in some sense is also doing SETI. We're making large surveys of the sky at all kinds of different frequencies with different tools, and we keep trying to encourage our colleagues in the astronomical business that as they're looking through these data sets, vast quantities of data, to keep an eye out for any anomaly, because it could well be that the sort of probe in the solar system or some vast astroengineering construct shows up in a data set as an anomaly, something that wasn't expected. So we keep trying to say, don't throw it away.
That anomaly could change the world.
Yes, 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 and we have such a wonderful example in Jocelyn Bell as a graduate student detecting the little bits of scruff in the data that weren't expected but turned out to be pulsars.
As you've said, the search is not directly looking for intelligence, but for the technological aspects of that intelligence. And I'm wondering about how our own technology affects SETI in the way that obviously as our technology improves, the search accelerates, but also as our own communication technology changes. What implications does that have for our understanding of the way in which the aliens might be communicating?
Well, it's difficult to project into the future how things might go, but I can say that it's pretty noisy out there now on the sky. We have all of these satellites and communications networks, and even on the ground, although we're using fiber more and more, there's still a lot of reasons for signals being transmitted. And it just makes our job harder. Our telescopes have to go into more and more remote places to get away from people and in our electronics. People suggest that, well, you know, now that we're doing this direct broadcast of digital stuff, and we're not doing the old analog large angular broadcasting systems, we're going to go radio quiet. And actually, I don't think so, because even a satellite directly broadcasting down to Earth has a back lobe, and although the power in that back lobe is smaller than the power in the front lobe that's transmitting, it's not trivial, and we've got lots more of them than we used to have. So I think the radio presence will continue.
I read a book recently, The Eerie Silence by Dr. Paul Davies, and I found it curious that he himself is a supporter of SETI. I think he used to chair the Post-Detection Task Force, which is sort of prepares for how to handle the follow-up to a signal detection. But in his book, he makes the case, or he at least suggests that there is a possibility that we are alone. So he's a bit of a skeptic.
He's just a scientist.
Well, that's okay. So that was my question.
It's an unanswered question, and you know, Paul is also a good entrepreneur, and he took advantage of the 50th anniversary of Frank Drake's first search to write a book. And one of the points that Paul makes, which I agree with him completely, is that we should think more broadly about how we look. And at the SETI Institute, we're doing everything that we can, and I'd be delighted if Paul got in the game and instead of just writing about it, actually began to do some of the searches he suggests. We absolutely reserve the right to get smarter as we go forward. And it may be, as I said a little while ago, a serendipitous detection through astronomical research that allows us to finally say, oh yeah, of course, that's what they're doing, and this is the evidence.
So granted that as you've said, it's a scientific question, and it's not really something to believe in or not. I'm still curious about the psychology of the search and the searchers, and whether most of those involved in SETI haven't placed wagers in terms of, you know, whether there's a signal out there, whether we would have some hope of finding it in our lifetime. There must be, when you don't have the scientist's hat on, there must be some feelings about how the search is going. Do you get a feeling from your colleagues?
Well, there's certainly folks that have placed bets on the Long Now website. In terms of my colleagues, nobody gets into this search without understanding what a big job it is they're taking on. If you wake up in the morning and you say, I'm going to get a signal today, right? You're likely to go to bed disappointed. But if you wake up in the morning and say, oh God, how can I make that search better? How could I do something different? What can I invent that will perhaps move us forward? Then you're going to more likely have a very satisfying and successful professional career. Just what we do today relative to what Frank Drake did 50 years ago, it's at least 14 orders of magnitude improvement in the capabilities. And along the way, perhaps, as we go trying to develop instrumentation that's looking for something other than what the astronomers would typically look for, there might be some technology spin-offs from that. And you know, people always ask this question, and I actually can't come up with a better answer than the one that Phil Morrison and Giuseppe Cocconi provided in the last sentence of the 1959 paper in Nature that they wrote on SETI. And that last sentence said something like, probability of success is difficult to estimate, but if we never search, the chance of success is 0. So most of us in this project figure we're going to search.
I've also heard you refer to another scientist who's described SETI as the archaeology of the future. And I'm wondering if by that the justification for the program is just given the momentousness of the discovery and the fact that if we don't look, we'll never find it. You know, when you do a cost-benefit analysis, it's just definitely worth the look.
I certainly think it's worth the look, and hopefully there are enough people in the world who are similarly inspired and willing to finance the effort. Yeah, it was Phil Morrison again who had that lovely phrase that SETI is the archaeology of the future. Mm-hmm. He was very specific. I mean, it's archaeology because if you ever get a message, the finite speed of light means you're learning about their past by the time the message gets to you. But it's our future that he's talking about, because if you detect a message, even if you can't understand the information content, at least at first, you still learn something immediately that's hugely important. And what you learn is that technological civilizations, on average, can survive for a long time, because you're never going to have a successful detection unless two societies are close together. Not only close in space, so that you're sensitive enough to hear the signal, but lined up in time. We are an incredibly young technology in a galaxy that's 10 billion years old. And we have no idea whether it's possible to become an old technology, old in cosmic terms. But the first successful detection tells us, yeah, technology can survive. There are others out there that we've been lined up with, that we are co-temporal with. So there is a solution. Someone else made it through. We got to figure out how to do that as well and become an old technology.
You've been a participant in something called the 100-Year Starship Symposium.
Right.
And I suppose that is largely about not just what the science and technology would be like over the course of the next century, but also the implications, how it would affect our society. And I'm wondering if you can comment, just as we near the end of our conversation, on the implications of finding a signal, an unambiguous signal, in terms of how it would change. I mean, our technology would, you know, depending on what the signal was, could be completely revolutionized. But how it would affect just the human species more on the philosophical, or dare I say spiritual level. Could you comment on that?
Well, I think that it would change just about everything, and I think it would change it in a positive way. For me, that understanding that it's possible to survive means that we, in fact, need to see ourselves as all the same when compared with them, and that we can work globally to manage these really difficult situations like water security and food security and climate change and all of these things where we're really having a hard time figuring out what to do in terms of working within our own countries. These are all challenges that are transnational. They require solutions that are cooperative and across boundaries. And I think that the idea that we become able to see ourselves all as Earthlings because there's something else out there that is so different that the comparison is forced on us. I think it's good for the planet. I think working on SETI and supporting SETI is in fact investing in our future. I think it's a stepping stone, maybe even just a baby step of the kind of collaboration and cooperation that we need to grow into in order to grow old on this planet. So the 100-year Starship.
So you're an optimist. So you're definitely an optimist.
I'm an optimist. the alternative is worse, right? The 100-Year Starship is an amazing program being run at the moment by Mae Jemison, an ex-astronaut in the US. And the tagline that has come up from this, and I think we'll keep for a while, is Pathway to the Stars, Footprints on Earth. So it's a big, audacious challenge. I don't know if we can do it. I mean, there may even be some fundamental physics that says, no, it isn't doable. But in the same vein of Arthur Clarke's second law about the only way to discover what's possible is to try the impossible, I think it's really worth working on this project. And the payoff will be to those on Earth. If we, a starship, a closed ecological life support system, well, if we could do it for a starship, we can certainly do it for mobile hospitals and all kinds of environments on the planet that need that sort of thing. DARPA put the seed funding into this project. What was DARPA's interest? Well, hell, they'd be happy, for example, if in studying how to have long-lived power systems on a starship, you could come up with a better battery. I mean, the modern soldier apparently goes into the field, if they have to. Someday maybe we won't have to do that, but at the moment, they've got 17 pounds of batteries in their backpack to take care of all of the electronic gear they've got. So better batteries that came out of trying to solve this audacious project of going to the stars. Lots and lots of things could come back to enrich us on Earth as we try this bold project.
You will have to forgive me if my last question is about the film Contact, because you are sitting in a room with a lot of folks who I don't want to put words into their mouths, but I'm pretty sure that Carl Sagan is a big hero to many of them, certainly to me. And we love that movie. We just watched it last year at a Center for Inquiry event in honor of Carl Sagan Day, which is coming up in about a month. So just tell me what role you played, and well, we know the character in the movie had something to do with you, but in terms of the production of the film, what was that like?
Actually, that was a great joy. It was a lot of fun. I was able to speak with Jodie Foster on the phone for a number of weeks before they actually began filming, and then I went down to Arecibo when they were on location there. And for me, it was a very special pleasure to be able to take Jodie up the catwalk into the Gregorian Dome, overlooking the dish and looking out on the island of Puerto Rico and saying, well, see, Jodie, this, for an astronomer, is our cathedral, right? This fantastic dome and the technology beneath our feet. She's a very, very intelligent and very kind woman. So it was a privilege for me to work with her. And I loved the movie business. I mean, if I weren't doing what I'm doing, I would have been really tempted. There's an amazing amount of technology that goes into making a movie. So I hung around with my mouth hanging open quite a lot behind the scenes, looking at all the cool stuff that they had to play with.
Jill Tarter, it's been a real honor having you here at the Star Spot at this special Center for Inquiry Fall Equinox celebration event. Thank you for joining us.
Oh, thanks for having me. It's been a lot of fun.
So Jill has to run off at about noon, or just after, and it's about 11:30 now. So if anybody has questions for her, she's agreed to take a few. Could we just use the mic?
Given that we have very limited scientific resources, has it ever frustrated you the amount of those resources that have been dedicated towards man's space flight?
So I always, let me use this, I think it's to our detriment to ask the question that way. You asked, does it frustrate me that funding goes to human exploration in space rather than to, say, SETI? And my answer to that is the funding should be increased for both, right? I think that the whole scientific endeavor is something that should be supported at a much higher level than it is. And I don't think we do ourselves any favors by trying to pit one science against the other. I think if the rationale is sound, the questions are important, and the methodology has been reviewed and approved, I think we ought to do it. And it goes across the board of all sciences. It makes me really unhappy, particularly in my country now, to see science losing respect, right? We don't, and it's crazy because as our civilization gets more complex, it's scientists, technologists, engineers who understand the way things work that are really far more valuable. And to be denigrating the science, it's just terrible. It's the wrong way to go. So, yeah, I'm a little ambivalent about the question because I applied to be an astronaut a number of times. And listen, we have folks working at my institution on Kepler and on the Mars Reconnaissance Orbiter and Mars Express, and these robotic missions are phenomenal, but I think human exploration also has its place.
I have a question about what happens if you actually see a signal. I guess most of us assume that it's an unambiguous signal. There'll be a huge effort to explore that signal more thoroughly, but if Murphy's Law is healthy, presumably what the headline would read is, SETI scientists 95% confident that signal is from an intelligent source or has some pattern or something. Presumably, when you have to go to politicians or after such an event, it might be a harder sell than you might imagine. I'm just curious what follows a signal like that if you see something that you're pretty sure is real, but you still have to go with the statistic.
Yeah, actually, I'm interested in your point of view because I've always thought, boy, if we get the signal, then the rest of the funding's going to be dead easy, right? Because everyone's going to be wanting to be part of the action, building larger arrays so that you can capture fainter information. I mean, the thing that I worry about most is the premise that you came up with, that I was sure that we had discovered something interesting. I worry a whole lot about getting to that sense of surety. I worry about hoaxes. I would very much not want to make a false announcement, to cry wolf. So we think a lot about how we can verify and get independent confirmation of a detection. Sometimes it might not be possible. We actually observe at radio frequencies for which no other observatory has the appropriate receiver systems. So the independent confirmation is really important to me. Telling the world is important, and telling the world in a way that hopefully gets the right story out there. Our thinking along that line is the fact that the world's media are not going to be able to call up the Discovery site and say, tell me what you got, what does it mean, right? Because it will just be too much of a bottleneck. So what we've decided to do is to make the information, the discovery information, available through the IAU telegram system to all the observatories around the world. Every observatory subscribes to this system. And that way, we will have informed, educated, a cadre of astronomers around the world who therefore can hopefully be the local resource for their media. And be able to interpret and not over-interpret actually what's been found and what it means.
What happens if we find some Earth-like or Earth-sized planets relatively near Earth, like within a 30 light year radius, as far as getting the public's enthusiasm for more detailed astronomy, more detailed Earth scale?
Well, I'm really excited about the possibility, I would guess I'd say high probability, that in the next year, 2 years at the most, astronomers are going to be able to say, right there on the sky, right there, that's Earth 2.0. That is a planet that's Earth size, Earth mass, orbiting a sun-like star, and at a distance from the star where you could, there would be the possibility of having liquid water on the surface. I think that's going to be a very concretizing event. I think once the public can understand, not just in the abstract, that there are other worlds out there and some of them might be like ours, but being able to say, that one right there, it's kind of like home. I think instantly the questions are going to be, well, can we go there? Does anybody live there? And I think it'll be a big boost for a lot of the different kinds of scientific explorations that we're thinking about. I think it'll also be a disappointment, because the answer is going to be, no, we're not going to get there anytime soon, not with what we know. But I'm looking forward to Earth 2.0 and seeing how it changes the public discourse.
So to follow up to that, if SETI did have a lot of money, do you contemplate SETI going into space in research? You know, if you did have Earth 2.0, presumably you want to go there looking for things, maybe not intelligent right away, but intelligent right away, but at least having SETI presence in space, looking at those parts of the planet.
SETI in space is an interesting proposition because what we need is not small collecting area, we need a lot of collecting area. And think about it, our biggest sources of interference right now are those satellites in orbit. So if you're going to be in space, you need to be above them, and you probably need a big shield behind you because the satellite back lobes are still radiating. And that makes you think about the one location in our solar system that never has the Earth in its sky, and that's the lunar far side. So in 1979, astronomers got the International Telecommunications Union to define the shielded zone of the moon, which is you go up to, I'm not remembering now, you go up to an orbit that is significantly above geosynchronous, and you draw chords, tangents to the moon, so those tangents hit just a little bit behind the terminator, and you say, from there on back, you should be protected from transmitters. It should be radio quiet. And then we started thinking about building a telescope on the moon. There's one on the drawing boards right now for extremely low frequencies. And it's essentially big, long dipole wires that are embedded in this sheet of plastic that's all rolled up in a little tiny tow truck that would be dropped, and then it would unroll in two directions, so you get two senses of polarization. This very, very low frequency antenna. But there's one thing about that, it has no moving parts. If you start thinking about building an articulated structure, a telescope, an optical telescope, because it's dark half the time, right? or a radio telescope that moves. We're really not quite sure how to deal with the lunar dust problem. The lunar dust gets into everything. It seems to be charged, and it's hydrostatically lifted or something. We just don't know whether you can, in fact, protect instrumentation from that regolith, that fine dust. So there is a mission called LADDY that just launched to try and better understand the nature of lunar dust. Because the Apollo astronauts came back with dust in everything, including their lungs, because the dust got into the space, into the lunar module, and then got ingested by them. So it's a great place, potentially, to build observatories at frequencies that the Earth's atmosphere blocks, and where you are out of the line of sight or the line of broadcast from our own technologies and interference. But it may be hard to do. And then, of course, NASA, in its infinite wisdom, has decided that the L2, the Lagrange 2 point, which is on the lunar far side, is going to be a great place to bring back spacecraft for repair or for construction. So that's not sounding very quiet to me.
Any other questions? Okay.
Well, I guess if nobody else has any other further questions, could you please give a big round of applause to her?
Think Again TV is produced by Centre for Inquiry, Canada's premier venue for secular humanists, atheists, skeptics, and free thinkers.
CFI Canada coordinates branches and campus groups across the country, runs a public education series, provides secular community services, incorporates cutting-edge multimedia such as blogs, podcasts, and YouTube, and is a regular voice in the press presenting a secular humanist, atheist, and skeptical perspective.